Hello, my name is Jonne Sälevä, and I'm here from Brandeis University presenting ParaNames, a massively multilingual entity name corpus. This is joint work with my advisor, Professor Constantine Lignos. So as introduction, consider that lists of named entities can be beneficial for many NLP tasks, such as named entity recognition and machine translation. And this is especially true for many lower resource languages. There are some existing resources, such as Wikidata, that can be used to mine lists of named entities, but as is, they have some serious data quality issues. So in this work, we address these data quality issues and release ParaNames, a massively multilingual collection of entity names, spanning over 118 million names, 14 million entities, and 400 languages. We have an extended abstract here at SIGTYP, and a full preprint available on arXiv. To create our resource, we ingested the Wikidata JSON dumps into MongoDB and stored a subset of all the fields available just to save disk space. And after we had done that, we started looking at the data and noticed several challenges with it. So as the first challenge, many language codes used in Wikidata indicate what script that language supposedly uses. So, for example, there's a language code for Kazakh written in Cyrillic script, but in reality, their data doesn't conform to these descriptions. So, in order to clean the data inside of each language code, we resort to approximate script identification and filtering. So what we do is we leverage the Unicode script properties provided by the PyICU library, and we look up each character's Unicode script property in a name. We create a histogram of scripts and use the most frequent script property as the proxy for the script of a name. And then for each language, we use Wikipedia to look up a set of correct scripts for that language and then filter out all the names that have incorrect scripts. Then as a second challenge, we asked ourselves the question of how can we assign types to each name? Typing is often very context dependent, so we use the context that we have and use the Wikidata knowledge graph and the instance of relation. So in case an entity is an instance of Q5, Q82794, or Q43229, it gets assigned person, location, or organization, respectively. We note that this relation is transitive, so being an instance of any of the subclasses of these is also enough. Small caveat, we disallow this for per because we noticed that if we didn't disallow it, many obviously non-per entities ended up being labeled as per. This is also not one-to-one, so about 2.5% of entities get assigned multiple types. We leave these entities as is because disambiguation often requires context. All right, some experimental work. We show a sample use case for ParaNames by focusing on canonical name translation, which is the task of translating entity names from English to 17 languages and vice versa. Here's the list of languages. They're sampled to represent variation in geographic location, orthographic systems, language families, and typological features. We create our parallel data by splitting the Wikidata IDs, 80% into train, 10% into dev, and 10% into test. And we note that we split by Wikidata ID to avoid data leakage. We also prepend a special language token to each name to indicate the language. Our model is a character level transformer. We use standard hyperparameters and train for 90,000 updates. We evaluate based on one best accuracy, character error rate, and mean fuzziness in F1 score, which is computed using the longest common subsequence algorithm. Here's some results going from 17 languages to English. The best accuracy is attained on Swedish and Vietnamese and Latvian. This makes sense as all of them use the Latin script. Notably, the Latvian accuracy is lower than that of Vietnamese. This might be indicative of some challenges with inflection, which is present in many Latvian names. Next come Kazakh and Tajik. Both of them used Cyrillic script, which is nearly one-to-one with Latin. So it makes sense that they rank next. On the other end, performance is consistently worst on Hebrew. This is mostly caused by the lack of source side vowels, which the model must infer on the English side. Then going in the other direction, performance rankings are quite similar to the X to English direction. So Swedish and Latvian score highest. Both are in Latin script with relatively few diacritics. They're followed by Kazakh and Tajik. They're in Cyrillic script, which again is nearly one-to-one with Latin. Some notable changes that we observe: Hebrew and Arabic both undergo significant improvements. So Hebrew 130% increase in accuracy and Arabic 62%. This is most likely the fact that now there are no vowels on the target side that need to be modeled. Georgian also has a very phonetic orthography on the target side, so its accuracy goes up by 50%. And then in the other direction, Thai and Vietnamese both decrease substantially, Thai by 66% and Vietnamese by 39%. This is most likely explained by the tone and vowel diacritics used by both languages. In conclusion, we introduced ParaNames, the largest collection of entity names to date, covering approximately 14 million entities in over 400 languages. We believe that there's many potential applications of our resource. We experiment with canonical name translation as an example use case. Our resource is released on GitHub along with the code that's used to construct it. We're targeting quarterly updated releases to the resource. And for more, you can see our GitHub repository or our preprint on archive. Thank you very much.